Okay, thank you.
Thank you.
Next one is the present. It's very hard.
Very what?
Very precise, so it's
Oh.
difficult to have questions.
Oh.
But very present.
Oh, cool. Thanks.
Could you please maybe put your presentation in the USB stick?
Yes. This is a USB stick. Wow. Oh, cool.
Okay, so this is to talk about an experimental talk about performance in JavaScript and relating it to Smalltalk. Sorry, I'm talking into the microphone. So I'm building an environment that is a data flow environment similar to the talk this morning for the web. And so Amber is this cool environment where you can program in a typical Smalltalk GUI, but it runs on the web, and it's very neat in all sorts of ways. But it's slower than I'd like it to be, and although it has a clever way of interfacing to existing non-Smalltalk JavaScript objects, the way it does it is actually has some really bad performance. And despite the fact that I've been programming for 40 odd years and teach computer science, I can't figure out how to do some things that I need to do in it. So that for me usually translates into it's time for me to do something myself with it. And I was curious about how close you could make JavaScript objects to Smalltalk objects. Okay, so here, does everybody know JavaScript perfectly? No? Okay. So this is a simple example I got from the web, declaring some two classes, an animal class and a rabbit class. And JavaScript doesn't have classes, okay? But everybody wants it to have classes, so everybody goes about trying to find ways to make it have classes. So this is one of the sort of standard ways to do this. So in JavaScript, when you want to create an object, you say new to you apply the new operator to some function. And so here we're declaring animal as a class, if you like. And when you say new and the animal, you provide a parameter list, in this case the name of the animal, and this allows it to store the name in an instance variable. This is a strange object, or a strange thing in JavaScript. It's almost like self, except a little bit different, which we'll get to in more detail later. When you do this new, it creates a new object. So JavaScript does have objects, but not classes. So it creates this new object, and it sets its prototype field to point to, it's actually called __ proto, to the prototype field of the function. So functions in JavaScript can have fields just like anything else can. So this sets the animal prototype to have two fields. One is a Boolean, can walk, and one is a function called sit. Okay, and sit just changes can walk to be false and just throws up a prompt. Now, rabbit is going to be an animal. So we declare a new function rabbit, and I don't have the code for inherit here, but it basically just fills in a few links so that the prototype field of rabbit will point to the prototype field of animal, so that you'll get your typical inheritance. And then we define in Rabbit's prototype a jump function that is going to set can walk to true and then jump. Okay? And here's how we create a rabbit. We say new rabbit, we give it a name, and store it in a variable. Then we can call the methods on it in the way that looks familiar, or sort of familiar to Smalltalkers. Okay, so I hope that was enough for everybody. This is what the structure looks like for JavaScript inheritance. So there's this thing called object, and it's a function, and it is the class, if you like, of every object in the system. So it has a prototype field, and its prototype field points to this top green box here, which is the proto object for the default proto object for every object in the system. And that object's proto field, the underscore proto underscore underscore, points to null. In other words, it's the end of the line. So when you're searching for a message or a field in Smalltalk, so here we've got an object from a user class, and when you try and access a field, it looks first the fields in this object. If it doesn't find them there, it follows the proto field to this, which would be the proto type for this class. If it doesn't find it in the fields or fields here, it follows to the fields of whatever this prototype proto was, which is in this case object. If it doesn't find it there, it goes to its proto field, sees it's null, and says the object doesn't exist. Okay? And then there's just this default thing. When you do new in a function, it sets up this constructor field to point to the function, the object from which to which you applied new. So this is kind of like Smalltalk in terms of all these links. This is the classic Smalltalk classes, which everybody directly or indirectly is familiar with, where we have proto object, object, and so on and so forth. These links, the solid links, are superclass links, and the dotted lines are class links. Okay? And to remind everybody, so these are the classes, and these are the meta classes. So, there's a couple challenges here if we want to make JavaScript classes match Smalltalk classes, and that is that there's some cycles in this graph. And in standard JavaScript, there is no way to create cycles in the prototype graph. So, let me talk about Amber a little bit, and then I'm doing for time. Oh, I'm way over time. Okay, I'm going to have to go really fast. Slightly slower than that, but basically instances of, it's a sort of a condensed class structure from Smalltalks, so all numbers are floating point numbers, because that's the only kind of number that JavaScript has. Classes that have a corresponding class are represented by that class. And so identifiers in JavaScript, whether they're functions or data fields, are all accessed through the same search mechanism. So they add an underscore to the beginning of method names, and they replace it in colons with underscores. To access variables, they add an @ sign to the beginning of it, which unfortunately means you have to use this syntax instead of this syntax to look them up, which doesn't matter too much, but. Okay, so the semantic map. Everything's an object in JavaScript, just like it is in Smalltalk, except null and undefined. Null is used in a few things. Undefined is what things are if they've never been defined. So if you create a new object and you reference a field and that field isn't found, its value is undefined. Does not understand, there is no such thing as does not understand in JavaScript. What will happen is that when you reference the field as a function, you'll get undefined back. When you try and call that as a function, you'll get an exception, which you can trap, but not in the way that not in a useful way. Boolean in Smalltalk obviously is just true and false. Otherwise you should be getting a must be Boolean error. Must be Boolean should be called rather. Self refers to current object, super. This can be done in JavaScript. There's a special call you have to do to say, call this code, this function, with this object as this. Otherwise it works okay. Yeah, so don't have to worry about that. And return from a Smalltalk block returns from the method in which the block is statically defined. And that's a bit of a challenge, but here's how you do it. Here's a JavaScript block that returns from the block, returns n, and that n should be returned from foo. And here's how you do it in JavaScript. Basically, you create a value, and this will create an object that is brand new in the system that can't possibly exist anywhere else. And then from within the block, which is a function, you just throw the value that you want to return. And then in the catch block in the foo function, which corresponds to the method, you check to see if it's equal to exit. And I left a piece out here, sorry. This should say throw $exit is assigned n. So this assigns exit to n and then throws it, and then it's easy to catch. Okay, and I'm now down to 8 minutes. So this is the structure that I have managed to create with Amber Direct. It has pretty much everything the way you'd expect it to be, and it fits more naturally with JavaScript because we have constructors referencing their creators and so on. So this object is essentially the method table for objects, for instances of this class. So its prototype field points to this object. In every instance of it, its proto field points to this method table. Then the method tables are all linked together. So when you call a method on your instance, it will not be here because we're only storing fields here. It will follow the proto to here. We'll look through the methods here. If it doesn't find it, it will follow the proto to the superclass method table and so on up the line. And at the end we have proto pointing to null. The only difference for classes is I still have meta classes. I don't have a method table here because there's only going to be a single instance of this anyway, so I just store the methods in the class object itself. Okay, so I ran a bunch of benchmarks. So classic Amber, or Amber, is designed to run on legacy browser engines. And that means that you have to create objects by saying new and a function. You can't mess around with the prototype structure. You can't create cycles in that structure. But as of this early 2014, essentially all the major browsers have supported set prototype of, which allows you to create whatever arbitrary structure you want. So I ran a bunch of micro benchmarks on this machine. IE11 I ran on a virtual machine, but everything else I ran directly. It's 100,000 operations at least in every run. And I didn't really, I did this because this warm-up runs, because on IE and Press, this was because of the virtual machine or some other feature of IE11. I was getting abysmal performance when I ran my benchmarks, but I kept running them, and then I noticed that after half a dozen runs, they started to get better. And after 10 runs, they're pretty solidly as good as they're going to get. So I did this with all the tests. I ran warm-up runs that I then threw away. So these are various, so what I was looking for is how to do the things that I need to do to map Smalltalk to JavaScript as efficiently as possible. So here's a simple example. If I try to test something, I need to know if it's a Boolean or not. And if it's not a Boolean, then I want to raise some error. What Amber does is calls a function called as Boolean, essentially, up at the top, which does a test similar to the second line. Yes. Now you would think that instance of would be the fastest way, with the fourth one there. You would think that that would be the fastest way on all browsers, because the browser manufacturer would say, is this an instance of? And they would be able to look up in the most efficient way possible. Turns out it is for many of them, but not for all of them. And as you can see, the performance on this, there are many ways that you might test to see if something is Boolean, and the performance is all over the map. There's almost nothing that is consistent. Instance of is actually the best, or near the best, for all of them except for one of them, and for I think it's Safari. No, anyway, it doesn't matter. It's the best except for one of them. So that's actually what we'll use. Here's the next challenge. So Amber throws three things into one test. That is to see if, so every time before it sends a message, it has to make sure that it's not null or undefined, because you'll get an exception if you try and send a message to either of those. And they want to handle does not understand properly. In particular, they want does not understand to work properly for ordinary JavaScript objects that are not part of the Amber Smalltalk system. So what they do is they check to see if the thing is null, and that actually captures undefined and null. If it is, it returns nil. So it returns the nil object, and now you can send messages to it, and everything works properly. Otherwise, it does a bunch of checks, and if it basically decides it's not an Amber Smalltalk object, then it creates an instance of JS object proxy and wraps the JavaScript object in this. Then when you send a message to this object, what happens is it will catch the unknown name and will allow you to access JavaScript fields or functions. The problem is that it creates these dynamically every time you send a message to a JavaScript object. So the cost complexity of that is pretty high. So what I basically do is I create those. So the way you have to catch this is you have to actually have a function with the appropriate name. So they put it inside this JS object, JS proxy object. I put it in the default object class. So when you call a method on that class, it goes directly to that code, and that code can then respond appropriately. Okay, so I'm very short on time, but so these are getVar D is the direct version, my version. GetVar P is the proxy version, and in all cases, essentially the proxy versions are dramatically slower. Timings here are all relative timings, so don't worry about one browser versus another. The fact that this is lower just means that it has some ones that are higher. But the direct version is significantly faster in all cases. This is another example of, so once you've taken, this is checking to see whether, right, so the previous one was handling the undefineds, this is handling the null pointers. So again, we get various different possible ways of doing this with fairly different parameters on different engines. This one is slightly interesting. So the way that they access fields in JavaScript objects is by using the index form, the one where it's index form with quotes, because they use a word that is not valid syntax for a field. And that works just fine in most of these, except for in Safari, where it is dramatically slower. So switching to using names that are valid as valid syntax allows you to use the first forms, which are significantly faster. This is to do numeric calculations, which are obviously a significant part of most programs. The first one is the one that Amber uses, but it doesn't do any checking. So if you send a plus message to something that's not a number, then it will, oh sorry, no. Yes, the one that Amber uses is actually the blue one up there. Sorry. They send a message all the time because they didn't want to do the analysis to decide whether it was safe to send it or not. So the last one there, you can see, performs just as well as any of the others, and it allows you to completely capture the semantics of checking to see if it's a valid number or not. So, conclusions. It turns out if you're willing to abandon legacy browsers, that you can make JavaScript align very well with Smalltalk, so that the class structures are almost perfectly matched. And you can get very close to native JavaScript performance if you're willing to do enough analysis. And I found some surprising performance characteristics. This would provide information for Pharaoh.js or Amber people to try and improve their performance. And I'm currently working on adding the direct object handling to Amber. And numbers are obviously the next priority. And I have -1 minute to take questions, so I will just close. Thank you.
One question? One question. Is this all? Just a question.
All right, yes. I saw micro benchmarks. Did you try it on real-life applications? How does it feel?
I haven't gotten to a point where I can compile. I've done hand versions of them, and I can get to within basically an order of magnitude speed up versus Amber. So to within less than a factor of 2 of pure JavaScript.
Okay. So what is missing for you to compile real applications? More or less.
Working through the Amber compiler to get it to the point where I can actually make it happen, because it's the compiler is fine, but converting, like migrating it is really challenging, or has been really challenging.
Okay, thanks.
Do you need another pen?
Oh, this is not. I have one. Oh yes.
Good afternoon. My name is Boris Shingarov. What I want to describe here is a debugging system based on running the debuggy VM inside a full system simulation where the connection between the outside host Smalltalk and the inside debuggy Smalltalk is over the GDB remote serial debug protocol. The actual need for such a debugger came out of another experiment, which I had described at another conference last year, but a lot of people here asked me to provide some context what that experiment was. So I will quickly recapitulate what I was trying to do. The attempt was to create a JIT that would be programmed without any knowledge of the actual target processor. So you start with a formal processor description written in a formal language called ArchC, and I will show you how that looks. It describes a number of things inside the processor. It describes structural things like which registers it has, how much memory it has, what is the word size, what are the special registers, and so on. It describes the instruction, the structure of the instruction decoder, so that you can see things like this is the description. This is the formal description of PowerPC processor. So it has instruction formats with the different fields inside the instruction, and the widths and the names of the field, which can correspond to the name of an operand. And then you've got descriptions of which instructions belong to which encoding. And then you have a bunch of descriptions of what each instruction does semantically. So you've got a transfer tree, for example, for each instruction, saying, well, if the processor executes this, the semantic effect is this. And then this thing that I have, what it is first of all, the front end is a petit parser-based parser for these PDLs. So, for example, if you parse that PDL that I showed you, you will get an object, a C processor description, and there is all the information that's contained in that PDL, and you've got a dictionary of the various instruction formats. This is too big, I will try to make it a little smaller. And this is different formats that are understood by the decoder. You've got instructions, and that is another dictionary. So as the key, you have the instruction name. And let me show you, let's say, well, add immediate is one particularly interesting one because we will be using it for our experiments just in a moment. So what you've got is you know what? I'll just take it by name. So yeah, instruction add immediate, and this is my inspector on this. So you can the tool is nicely integrated with the GP inspector. You can see the format of the instruction. You can see the the actual definition of the semantics. There are two semantic trees, depending on whether the operand register is registered to register 0 or not. And it actually shows you in the formal rewriting system what rewriting code actually results. What that does is that, well, in order to do actual instruction selection,